Now coming back to the voice telephony part. So the analog voice band channel, a channel that is suitable for transmission of speech or analog data and has the maximum usable frequency range of 300 to 3400 Hz. So that is the frequency range that it should be varied when we use our voice telephony. So when we use a speech as a medium of communication through the channel. So the local serving switch is the point of the connectivity with the PSTN. PSTN means, in previous lecture we came to know about public switched telephone network, and it is the point where the analog signal is digitized. So it's also an important part that the analog signal, that is the analog voice band channel, so it should have to be digitized if we want to spread over through the channel in modern telecommunication systems. So here you can see that how the range of hearing and the hertz is related. So as we say, the span of the frequency is from the 300 hertz to 3400 hertz. So what is the really the important thing that is the communication will rely on it? First of all, we need to know the range of human hearing. That what is the range of human hearing? That's a very popular thing that you have came to know in the previous studies you have done on the past. That is the 20 hertz to 20,000 hertz. So that is the level of a range or level or range of a human hearing. This type of frequencies the human can hear. But what is the voice frequency that really go through to it? So when we really transmit our voice frequency, that may be a general frequency, that may be a range of emotions that you have seen in the previous curves in the previous slide. But here you can see that there is a bandwidth of 300 hertz to 3400 hertz. That is the range. That is the range of our communication as a voice communication, and that also resides on the range of human hearing too. But that is the bandwidth of analog circuit. So we have to make the analog circuit with this within this range. So whenever you design a telecommunication system, you need to know this range. You need to make the channel, you need to modulate your signals within this range from 300 hertz to 3400 hertz. So that will be the bandwidth of the analog circuit that should collectively take the analog signal, that is the voice signal, and process it for your telecommunication networks. And there may be a guard band in two parts. As you know, there are 200 kilohertz guard bands that has been now a very popular figure in the telecommunication systems. The 200 kilohertz guard band in the voice frequency, if we take that is the guard band means channel separation. We can separate different type of channels in the frequency spectrum by this. That means here is a bandwidth that you can communicate. There are other bandwidths that other channels may occur or may take to part in that particular point of view. Otherwise, if we are not able to make channels, we can't able to communicate, or we can't able to just take the other subscribers to subscribe, or you can say the other users to use the channel and communicate with each other. So that's the part. And now the bandwidth available for analog voice transmission has been now just squeezed on a certain part. So if you take, there are certain guard bands in certain point of view. In some voice transmissions we popularly use 200 kilohertz. That doesn't mean that always the 200 kilohertz will be used in the as a guard band. It will be used as far as the situation, as far as the communication. So that can be changed, but there are some standards that we can take the guard band as 200 kilohertz. And the voice, so and the bandwidth available for analog voice transmission now has been shrinked now has been shrinked by these two guard bands. So we have to put the two guard bands under the 20 kilohertz and the 4000 kilohertz. Now you can see we have to remain the 300 to 3400 hertz within this range. We are not giving any kind of range out of that. Now you can get minus it to 320, you can get 280 hertz and 3400 to 4000 to 600. So there are the guard bands related to this. You can use it as your purpose. That's not the thing, but the design of the analog circuit should have to be spanned for 20 hertz to 4000 hertz. That means 4 kilohertz. Why? Because our voice frequency is 4 kilohertz. That is 4000 hertz. That means 4 kilohertz. If you say what is the frequency of our highest frequency of an audio signal of a human voice, that is 4 kilohertz, and that is 4000 hertz. Same. So that is the upper limit of a frequency of a human voice, and the lower limit might be 20 hertz. But that is the thing that we should really design a telecommunication network and keep the thing on our mind while we are designing the analog circuits. Now that is the telephone subset. What is telephone subset means? It is a device which converts human speech in the form of sound waves produced by the vocal cord to electrical signals. These signals are then transmitted over telephone wires and then converted back to sound waves for human ears, microphone, earphone and signaling functions. Here you can see that is how a voice onto and off the network can be produced by this type of telephone offsets, that means telephone subsets. Now you can see here, so there are some sound waves. There is the inner sound wave, that is the granulated carbon that has been set on the telephony system to the receiver end, and that is the speaker end there, that we listen what other talks about us. So these are the things. There are some jacks there. There are the transmitter mouthpiece there that has been taken from here. The permanent magnet is set on the sound wave on the the microphones. There's the speakers, there's the microphones. We'll take it and put it through this. There are some wires. There's the RJ11 connectors. There's the LAN connections has been given here that we can really communicate with the voice onto and off the network. So that is the telephone handset. Telephone handset has the microphone, that the mouthpiece, that consists of a movable speaker diaphragm that is sensitive to both amplitude and frequency. The diaphragm contains carbon particles that conduct electricity. As the human voice spoken into the transmitter varies, the amount of carbon granules that strike the electrical contacts in the mouthpiece also varies, thereby sending varying along electrical signals out into the voice network. Now, telephone handset. There is an earpiece or earphone in that particular telephone handset that acts in an opposite direction to the mouthpiece. The electrical signal waves produced by the transmitter are received at an electromagnet in the receiver. Varying levels of electricity produce varying levels of magnetism that in turn cause the diaphragm to move in the direction proportional to the magnetic variance. The moving diaphragm produces varying sound that corresponds to the sound waves that were input at the transmitter. So that is the conventional telephony operation, as you can see here. So there is a person that are talking in that particular point, as off on a hook on a switch, and they have been connected to, that is the local telephone extension. So that is the switching element in a particular telecommunication switching networks. The switching matrix are there and they make a connection to another part that we want to connect it. So these are the connections, these are the variable currents and controls, that is the on and off a hook, delay or relay that makes the connections. So relaying is the main part of the telecommunication switching. So that's the end of the first lecture. That is the conventional telephony operation that we know. We know some advanced ones too. Thank you very much for being with me.